All right, we'll go ahead and get started here. Looks like it's just going to be us three today, which isn't a problem at all. But we'll start off. How'd y'all feel about the exam last week? Did y'all feel prepared, underprepared? How'd y'all feel?
Prepared until I was taking the exam, and I was like, "Oh, I don't know anything."
Was it a little rough?
A little bit, yeah. It wasn't my best work.
Yeah, same for me. I actually looked at her old previous test and I handwritten everything down, so some of that material was on the test, and I think I got the correct answers from what I remember.
Yeah, that's always the thing I used to do, is go upstairs and take pictures of her old tests and study those. That was kind of the best way to prepare for me. This unit that we'll be working towards the next exam, organic chemistry, it's either a very, very hard exam unit to cover, or it's easier if you know how to study. It's kind of hard to explain. This is kind of my best unit in the end, is kind of what I did the best on. So I'll be able to provide the most help for this stuff, especially in the future as we get into some of the more detailed stuff. We're just covering the basics today. But yeah, it can be really tricky unless you study and work hard on it. But after you kind of understand the concepts, it gets really easy from there. So we'll kind of just dive on in. I don't really have too much for today because she didn't cover too much information that's need to know. We'll cover what's on the quiz. But Thursday's SI session, and then every SI session from here on out, is probably going to be pretty in detail because a lot of this stuff is pretty hard to learn. But today it'll be pretty easy. We just have a Quizlet for some memorization purposes, and then we'll go over here and we'll name these isomers of pentane and hexane. And that's all we got today. So we'll start on this Quizlet. And the way I set this up is it'll give you the name right here, and then on the other side is the formula for each of the hydrocarbons. So does anyone remember what the formula for propane is, how many carbons it has and hydrogens?
I do not. I don't remember a lot of stuff.
That's no biggie. Actually, before we get into those real quick, let me go to this one. Okay, so the formula for alkanes, determining the amount of hydrogens and carbons. It's going to be, so the amount of hydrogens is going to be equal to 2 times the amount of carbons plus 2. So if you have 3 carbons, you'll multiply that by 2 to get 6, and then you'll add 2 to get 8 hydrogens. So that's how you determine how many hydrogens you have when you're dealing with alkanes. But the way to know how many carbons you have is really just through memorization. So propane. Oh, there we go. Propane is going to have 3 carbons, and then you multiply that by 2 and add 2 to get 8 hydrogens. And that's just something you got to remember. Propane goes to 3 carbons. There's no trick to it. It's just a memorization thing, which sucks, but that's organic chemistry for you. So propane is going to be 3 carbons and 8 hydrogens. And the only thing you really got to work on remembering is the carbons, and then you just remember the formula to get the hydrogens. So methane. Methane is the simplest hydrocarbon. I'll give you a hint. It has only one, or it only has 1 carbon. So how many hydrogens would it have?
Three or 4, I can't remember.
It'd be 4.
Okay.
So you have the 1 carbon.
CH4, 1 carbon and 4 hydrogens.
I need to turn that off. So you have your 1 carbon, and then you multiply it by 2, and then you add 2 to get the 4 hydrogens. And I really wish I could have done this session in person to kind of explain why that is. Let me see if I can open up a Word document real quick to kind of explain it. Stop share, share screen, Word document. There we go. And there we go. Okay, you can all see the Word document, right?
Yes.
Okay, so the way alkanes work, this is gonna be really hard. I might have to go into Paint or something. But let's say we have one carbon. Let's make it a lot bigger. We have one carbon. And then surrounding that carbon is going to be all hydrogens, right? Carbon, and the dashes are just bonds. And then if we were to go here, yeah, this is not going to be the easiest thing to do. There we go. Hydrogen. And same thing on the bottom. And hydrogen. There we go. So the reason that it's going to be times 2 plus 2 is for every carbon you're going to have, or for every, it'll be easier to explain when I do this. Hold on. Connect it to another carbon. There we go. And then I'll connect that one to another one. So we have, this will be a propane. You have 3 carbons, right? And we come over here, put in these, and put in some hydrogens. Something like that. H and H. Okay, so this is a propane, the Lewis dot formation of a propane. This was a 22. Oh, shoot. Good Lord. I am sorry, this is a little annoying. There we go. Okay, so that is your propane, 3 carbons, and 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. So like that formula just said, C3H8. So what you're gonna recognize is with all the hydrocarbons, all the alkanes, every carbon-carbon bond is gonna be a single bond. So in the future, we'll talk about alkenes and alkynes, and they have double bonds, and then alkynes have triple bonds. But for alkanes, you're just going to be dealing with this single bond between carbons. And so that means it leaves 3 spots open to form a bond on the ends with hydrogen. So this carbon, it's only taken up by 1 bond to 1 carbon. So it leaves 3 bonds open for this hydrogen. And then the middle one, it has 2 bonds to carbon, 1 on each side. So it only has 2 bonds open for this hydrogen, or for these hydrogens. And then you have another end carbon, a terminal carbon, I believe is the technical term for it. And you have 3 hydrogens. So terminal carbons are going to have 3 hydrogens. And then any carbons in the middle are going to have 2 hydrogens because they're already covered up. So that's why it's always going to be the same amount of, that's why there's a formula for how many hydrogens you have for the number of carbons, because it's kind of a set amount that won't change. Does that make more sense?
Yes.
We didn't explain that the best way. It'll get a lot easier as we go into some of the harder material.
Yeah, it makes sense.
Okay. Let me cancel that. And share screen again. Okay, so now we'll go back to this. So we started a propane. That's C3H8. And then we go to methane, CH4. So 1 carbon and 4 hydrogens. Since it's not technically a terminal carbon, it can have all 4 since it's not bonded to any carbons. And then we go to octane. And this is where it starts getting a little easier. Octane, octagon, it goes to 8, so C8. And then
C8H18.
how do I turn that off? I'm just going to mute my computer. That's easy. So as you get into the later ones, they have the prefix of whatever amount of carbons they have. So octane is going to have 8 carbons. Nonane is going to have 9 carbons. And then you just do the formula to get the amount of hydrogens. Oh, and then this is the definition for an isomer. Does anyone remember what definition of isomer is?
No.
I have it written somewhere. Oh, like the different
Oh, wait.
compounds with the same chemical formula?
Yeah, I forgot I muted my computer, so I couldn't hear you all for a second. But yeah, so compounds with the same formula but different structures, which is what we're going to be talking about here. So we'll dive into that in just a second. Get out of my way, please. Screen. Why? I don't like Zoom. There we go. Oh my gosh. There we go. Okay. And then decane. Can you guess how many carbons that's going to have?
Is it 10?
Yeah, it's 10. And then how many hydrogens would that correlate to?
22? Wait.
Yep. C10.
Okay, yeah.
Yeah, C10H22. And that's all you have to do for all of this. This is the formula for alkane. We just covered it. Septane. That's kind of a prefix we don't often use, but that is going to be C7, and then that would correspond with 16 hydrogens. So septane is C7. And this is another one of the ones. So let's go back into a Word document real quick. Stop share.
You said that last one was septane
Yes.
for 7. On her notes, it says heptane.
Oh, is it heptane? My bad.
Septane.
I
Septane.
must have just assumed. My bad. I took a note of the first 4, the C through C4, because those are the hard ones, and then I just assumed the prefix for the rest of them. But heptane is what's in our notes, then that's definitely it. It's not a very common one. We
Okay.
usually deal, in organic chemistry, we're usually dealing with the first 4, which are the harder ones. But what I was going to say is, if I can get a Word document up. What is going on? Share that again, and then open a Word document. And then stop share, share screen, Word document. There we go. Okay, so we talked about CH4, that's methane. Then we have C2H, what is 6? C2H6, that's going to be ethane. Then we have C3H8, that's going to be propane. And then we have C4H10, that's going to be butane. These 4, they're the most popular that we use whenever we're dealing with organic chemistry, because obviously this keeps going down, C5, C6, so on. But after these 4, it goes into the prefixes that we're more used to. So this is pentane, and then hexane, and then C7 is heptane, stuff like that. But these first 4, you notice methane, ethane, propane, and butane, they don't have specific prefixes that would tell you how many carbons you're dealing with. So these 4 are the ones you're going to need to memorize mainly. The C5 through C10, you can look at the prefix and know which or how many carbons you're dealing with. But with these first 4, you're going to have to memorize these especially. So methane is going to be your CH4. Ethane is going to be C2H6. Propane is C3H8. And butane is C4H10. I wish there was a way I could help y'all memorize those, but it's really just practice. The more you deal with these 4, the more you'll be able to recognize them and know what you're dealing with. So let's go back to this. Stop share screen, Chrome. And I think that about covers it. So ethane, that's going to be your C2H6 that we just talked about. Pentane, take a guess as to what pentane would be.
C5.
Yeah, C5, and then how many hydrogens?
12.
C5H12. Just because you multiply by 2 and then you add 2 to get 12. And then butane, you remember, I just talked about it. You remember which one it was? It's one of those first 4.
C4H10.
That's right, C4H10. I don't know if you were there for that Word document I just did, Brandon, but
I got the ending portion of it. Sorry, I had a lab report meeting at the same time. So
you're good. I wish I could have done it at the scheduled time yesterday, but my Canvas was just not working at all. It made me change my password, and then I forgot my password, and then the password service wasn't working. So it was just a big mess.
No, that's all good. Yeah, sorry about that.
No worries. Hexane, this is the last one for these. What do you think hexane is?
C6H14.
C6H14, nice. And that is all the terms. So we have methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane. Just 1 through 10, and those first 4 are the ones you need to memorize the hardest because they don't have the prefixes. So that covers all the memorization parts. I think that's the main thing that's going to be on your quiz tomorrow. If I remember correctly from last semester, the first quiz of organic chemistry was just naming alkanes. But she also covered this in a lecture, so we're going to go ahead and get into this real quick. This is naming the isomers. And I might need to have a Word document open for, I don't know how I'm going to do this. Oh, wait, maybe I can. Let me try something real quick. Word document. Like that. Make this small. And then grab that and move it here. There we go. Okay. That worked a lot better than I thought it would. Stop share. Share screen. Word document. Okay. So we're going to do these in order of, we're going to do the pentanes first. So 1, 2, 3, and we're going to go 4, 5, 6, 7, 8. So we'll start on number 1, this first pentane, which is just straight up pentane. You have 1, 2, 3, 4, 5 carbons, and there's no groups extending off of it. So you know that this is going to be just regular pentane. You go to 2. And what do we got here? We have 1, 2, 3, 4, and then we have a methyl group here, because remember a methyl group is when it's just one carbon extending off the main chain. So how are we going to name this? We're going to start by finding the longest chain of 4, which you could either do it including this. I'm going to just do it where horizontal is what we count for the most part, because that makes it easier just visually. But then we need to know how we're going to name the methyl group, because we could either do 1, 2, 3 methyl or 1, 2 methyl. Do y'all remember which one is the preferred method according to Dr. Schultz?
The one closest to the first branch.
Yep. So it's going to be 1, 2 methyl, and then what's it going to be? It's going to be 1, 2, 3, 4. So what is the final name going to be? I'll give you the 2 methyl. You name it based off of how many carbons you have in one chain. So we have 4.
2 methyl propane or butane.
Yeah, it'd be butane for the 4 carbons, and that's it. Just 1, 2 methyl, and then 1, 2, 3, 4. So it's butane, 2 methyl butane. So we'll move on to the next one. The next one, we look at it and we see no matter which way we go, we're going to have 2 methyl groups coming off of it. And we also know that no matter which way we go, we're going to have the longest chain of 3. So we can start at the end and make it a propane, and then we work out what we need to do. So what are we going to do? Well, we know that no matter which way we come from, the methyls are going to be at position 2, right? They're going to be at the second carbon. So we can start with that. We know that both methyls are going to be there. So it's 2, 2, 1, 2 for each methyl. So there's a methyl group on the first 2 and then a methyl group on the second 2. And then what do we say after that?
Dimethyl?
Yep, dimethyl propane. So we have, let's start from up top. 1, 2, and then we have a 2-methyl here. We have a 2-methyl here. So that's the 2, 2. And since there's 2 of them, it's a dimethyl. 2, 2, dimethyl propane because the long chain is 3. So we'll move on to the hexanes. 1. The first one is just hexane. 1, 2, 3, 4, 5, 6. So then the second one is going to be 1, 2, 3, 4, 5 with a methyl group coming off here. So see if you can come up with a name for this one.
So there's 2 methyl groups?
On this one, there's just one.
Oh, just the one.
Yeah.
2-methyl pentane?
Methyl pentane. Nice. That's exactly it. Because we have 1, 2, 3, 4, 5. So that's the pentane. And then we have a methyl group coming off here, and we can start counting from here to make it a 2-methyl. Move on to number 3 right here. We have 1, 2, 3, 4, or we have 1, 2, 3, 4, 5. So our longest chain is going to be 5. And then it's in the 3 position. So what would this be?
3-methyl pentane?
3-methyl pentane. Nice. And now it gets a little more tricky. We have this right here. We can go 1, 2, 3, 4 and have 2 methyls coming off here. We can go 1, 2, 3, 4, 2 methyls coming off here, or 1, 2, 3, 4 and 2 methyls coming off here. Either way, it's going to be the same molecule, no matter how we name it. But what do you think the name would be?
2, 2 dimethyl butane?
2, 2 dimethyl butane. Butane for the chain of 4, and then we start from here. So 1, 2. We have a 2-methyl. We have a 2-methyl, so it's a 2, 2. And there's 2 total methyls, so it's a dimethyl. 2, 2 dimethyl butane. Nice. And last one. This one is a little tricky. I'll go ahead and walk you through it. So we have a 1, 2, 3. So that's not it. 1, 2, 3, 4. That's going to be the longest chain we can make. So we know it's going to end with a butane, because there's no way to make 5 from this. So it's ending on a butane, and we have a methyl here and here. If we're, let's take this chain, so starting here. Oh, I can't do that. Follow the mouse. So we're going 1, 2, 3, 4. If that's our starting chain, then we would have a methyl on 2 and a methyl on 3. So in that case, it would be a 2, 3 dimethyl butane. So that's the name of this one. But what would be the case if maybe I can insert shape line. What would be the case if we had this? Think of that as another bond. I'll go ahead and put this as 6. It's a little more confusing now, doesn't it?
Yes.
Okay,
Way
so
more.
there's a few ways we can look at this. We can look at it as the way we were just doing it, 2,3-dimethyl, but now it would be a 2-ethyl and then 3-methyl. So that's one way you look at it. But is it the correct way? That's what we need to figure out. Well, this also could make it another continuous chain right here, which would make it a 1, 2, 3, 4, 5, which would make it a pentane. And then you'd have a methyl group here and a methyl group here. Which one of those two do you think is the proper way to do it? This is a kind of a trick question that she barely skimmed over. So if you don't know it, I completely understand.
I'm not exactly quite sure, actually.
Okay. So one of the rules whenever you're naming isomers is that you want to have the longest starting chain, or I guess ending chain. You want to have this, it's considered the base chain is what it's called. You want to have it to be the longest as possible. So instead of a pentane, you would rather have a butane. Obviously for these two, is that right? 1, 2, 3. Oh, no, sorry. I was thinking propane. Instead of a butane, you would rather have a pentane. But obviously for these, the longest chain you can make is 4, so you can't make a pentane. But on this one, we can make a pentane because we have 1, 2, 3, 4, 5. So we want that pentane. We want to end it on a pentane. So then that means we need to use that form. So if we're starting knowing that we're using this as a pentane, then we need to look at these as methyl groups instead of looking at this as an ethyl group. So if we're looking at these as methyl groups, then we need to start from over here and have it be a 1, 2-methyl, 3-methyl pentane. So it's going to be a 2, 3 dimethyl pentane. Because you have a methyl here, so it's the dimethyl. And that's on the second position and the third position. So it's 2, 3 dimethyl pentane. See how that gets confusing really quickly?
A little. So we go from the rightmost up to the new part
Yeah.
to make it bend.
1, 2, and then you have a
Mhm.
methyl on 2. Then 3 with a methyl on 3. Then 4, and then 5. So it's a pentane with a methyl on 2 and 3.
Okay. And then so we wouldn't want it to be an ethyl, right? We would want it to be the longest
Yes.
carbon chain first, and then we go off of if there are any ethyls or methyls, correct?
Yes, you want to get that longest chain first. So,
Okay.
because you could look at this and say, okay, well, we have a butane right here. We have 4 chain, and then we have an ethyl coming off this way and a methyl coming off this way. So you could look at it and say, yeah, that's going to be a 2-ethyl, 1 or 3-methyl butane. But according to the rules that she's giving us and what the quizzes and tests are going to be over, you want to have that longest chain first before you start divulging into the methyls and ethyls.
Okay.
Let me
Thank
try and give you one more. We have 7 minutes left, so I want to use them. I'm going to try this. This might not work as much as I want it to, but we're going to try it. So if we have 1, insert shape. Wait, I might try it this way. Oh, that's not what I want at all. Insert. Is there like a zigzag line I can insert? I don't think there is. Oh, I can draw though. There we go. Okay, let's start from there. Let's go ahead and delete that. So what do we got here? We have a 1, 2, 3, 4, 5, 6, 7. Oh, I don't like dealing with heptanes. So we'll make that an octane. So we're going to start with an octane. All right. And then shapes, draw. We're going to have one of these. And, oh, that's bad. That was bad. Insert shape. This is a lot easier to do on pencil and paper. There we go. And then there we go. And then we'll go ahead and make it a 3. Oh, no, actually, we can't do that if I'm trying to do what I want to do. It's really hard to come up with these problems. Okay, we'll do 1, 2, 3. We have a insert shape there. We'll have one here and insert shape draw. We'll have one here. We'll make that there. Okay, so this looks very confusing, doesn't it?
Yes.
Let's see if we can break it down. So we'll make this bonus. And this is way more in depth than she's going to go on this quiz. So don't look at this trying to memorize it for the quiz, but this is preparing you for what's to come, because this will be probably Wednesday's lecture. Tomorrow's lecture is this stuff right here.
Okay.
So let's break it down. We started with the octane, so we know it's 1, 2, 3, 4, 5, 6, 7, 8. But let's see if there's any longer chain that we made by doing all that, just in case. So if we start from here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that's already a longer chain. What if we go this way? 1, 2, 3, 4, 5, 6, 7, 8, 9. That's also 9. I don't want it to be 9. Shapes, draw. We'll put one more here. There we go. Okay, now we're ready. So we know if we go that way, it's 9. But now if we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, we have a decane. Sorry if that got confusing, but just so the base chain we're going to be dealing with is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's a decane that goes from here to here. So then we can start, now that we have the decane, we can start looking at these methyls, ethyls, and what have yous. So in that case, we're going to see which side we need to start from. So if we're starting from here, it'd be a 1, 2 with a methyl on 2, and then a methyl on 4. And then what is this? We have 1, 2, 3. So we know 1 is a methyl and 2 is an ethyl. So what is this going to be?
Propyl.
Propyl, nice.
Oh, purple.
That's going to be a propyl group on 5. Is that the lowest sum? If we go for this side, it's a 1, 2, 3, 4, 5. Propyl group on 5, methyl on 6, and a methyl on, what would that be, 9 or 8, which is going to be a much bigger sum. So we know we need to start from over here. So it's a 1, 2, 3. So we have a methyl on 3. Let me go ahead and move down here. So we have a 3 methyl. That needs to be a dash. 3 methyl. We also have a 1, 2, 3, 4, 5 methyl. And we have a 6 propyl. So what do we need to do with all this? Well, we know that the methyl is going to come before the propyl because of the alphabetical rule. So we need to deal with the methyls first. So we have a 3, 5 dimethyl, right? And then what do we do with propyl? We put a dash, 6 dash propyl decane. Does that make sense?
Yes.
Yes.
We'll walk through it one more time real quick, and then that'll be it. So it's a 1, 2, 3 with a methyl, 4, 5 methyl. So that's a dimethyl on 3 and 5. Got that. And then we have a 6 propyl, and then it's a decane when you get the long chain. That's all I got. That prepares you and more for the quiz that's coming up. So, and we only have a minute left, so I don't think I have time for questions. But y'all feel good about that?
Yes.
Yeah, I
Yes.
do.
All right. Well, I hope y'all have a good day. Thanks for
All right.
Thank you.
Thank you, you too.
Yeah, thank you so much. All righty. Have a good one.
You too. You got it? Nice.